Okay, hello. Today I'm going to go over this week's community case, Bungling with Zippy. I do get the reference. This image, given the introduction, means I am definitely neither too young nor not British enough, which makes me old and British enough, which I definitely am. So this was a really tough case. I always aim to keep these walkthrough videos under half an hour because that's how long we have to do the case. And if I can't do it under half an hour, then there's something wrong with my approach. So I think this is going to be one of those that tests my ability to do that. Looking at the scores on the community case, this was a tough case. I got less than half marks, but I'm still, although I've not looked recently, but was kind of definitely kind of above average for my normal performance. So this is a tough case. All to do with compression and decompression of data files, which is something I'd never looked at before, so was certainly new to me. Few things to kind of focus on. So I'll talk a bit about my performance as I go through, as normal, what I did on the first attempt. I've done some of the prep work so that this hopefully can get in under the half an hour, but I'm still worried. So yeah, let's get on with it rather than wasting any more time. We're already at a minute. So let's go to level 1. So we're dealing with the fact that this is actually not really introducing anything yet. So we're just looking for, in this case, the 12th word of this string. So what I'm going to do is I'm going to text split the string based on spaces, and that will have me a spill array. But if I wrap that in a index, and because I've split this out as a row, I just want to take the row stays the same and the column number will be whatever my value is here. And if I fill that down, we get a full sentence. Dermot has defeated 9 oiled competitors. In this particular case, the audience left because they felt sickened. A nice little bit of humour there to keep things going. Right, level 2, data tabled this because mainly just to show the workings out. So we get given a triplet, which is square brackets with 3 parts separated by semicolons, and we're given a series of those, and we're asked to pick the nth one, in this case the third, and the C reference, which is the third part of it. So I'm going to use, I spent lots of time I started by using text splitting, and I was trying to split on the square brackets, the colons, and all of those didn't really work very well. So what I realized is an opportunity to practice my regex. So what we were actually looking for is we've got 3 parts. So we're going to have, the first bit is always a digit, so /d to refer to a digit, and it could be double digits, so we put a plus, then it's followed by a semicolon, then it's followed by another digit, so always a digit, but could be double digits, so plus, then another semicolon. And then this was the tricky bit, because we can have anything in this third part, even a space or nothing, except for a closed square bracket, because that would actually mean the end of it. So we need to then create a set which ironically uses square brackets, and inside we want to say anything but, so we say the hat symbol, and then it's a literal square brackets. We have to put a backward slash to cancel that. So there's a lot of stuff going on, and that last item could appear none or multiple times. We put a star to refer to that, and I put that whole thing in speech marks, and we will extract the first one. So actually we use the optional argument 1 to get all of them, and just for the purpose of reading, I will to call that so we see all of them. Our index, we're going to basically say we want the index into that array based on the third row. So that's the item. We now need to split it into 3 parts, and now we can use our semicolon split. So text split this on a semicolon. And what I did originally was I basically did ABC as a kind of static range, then referred to it, and then highlighted this to give me F9. So that gives me the references for those in a column, because then what I can do is say X lookup this C in that range. So I paste that in there, returning from this range. So it will then match them up. So in this case, I get T, and that should be my answer. Which if I refer to that, and I'm just going to, I've actually written that expression here for use later because it'll save me time, because we're going to use that quite a few times. So that's level 1. Just check those have come out correct. Yes, they have. Let's go on to level 3. Level 3, so now we're given a triplet, and what do we have to do? We're starting to compress. So the variable A will be how many letters to move backwards from the end. Variable B will be the number of letters to read. Add the letters you get from B to the end of the text, and C is the character to append at the end. So let's start off with the same thing, in that we need to we actually need to regex extract from here that same expression. Let's use it reference here. And let's actually change that to the values, and then we want to text split that. Text split, and on actually I don't think I need to text split at this point because actually I will text split just because it's going to make this next bit easier, because there we go, those are parts. So the back step is basically index on that row 1, so that's how many steps we move backwards, that's the A value. Then we read the index of this 2, and then the character is index of that 3. So those are the parts. And then what we're going to do is we're going to start, and this is where I have to get my head around it, so we need to know the length of the string. We're then going to minus the number of steps back, but then we always add 1. So we're actually starting at character 2, and then our mid is going to be the text, which is in C1. Oops, mid C1. We're starting at the start point and we're reading this many characters. So we're bringing out the word bra, BRA, and then we're going to concatenate the original text string in C2 plus the mid plus the character on the end. And we get, oh, I've done something wrong there. C2, not C2, C1. And we get abracadabra. And if I use that and point to that, we get all of our words. But we're going to want to use this same set of skills. So what I did when I was practicing this was I set this up as a let statement, which I'm just going to show you here and uncomment. So this is my let statement, basically doing the same things, although actually I did instead of using index there, I used text between to extract the text, but the basic idea is the same. The start point is the length of the string minus the back steps plus 1. The substring is the middle part, and then the result is concatenating them together. And so then I'm going to turn this actually into a lambda that we can then use later. So to turn this into a lambda, I call lambda, my 2 variables are string, I'm going to put those in lowercase, string and triplet. So we're going to always give it a string and a triplet. I can then remove those as kind of variables from within the let, and if I just try referring to those, we should still see we get the same answer. And what I'm going to do, use OA robot to save the lambda as, and we will call this is decompress. We're taking triplets and we are turning them into text. Okay, so we'll call that a decompressed lambda, which is going to help us on level 4, because on level 4 what we're going to do is we're going to text split the string we're given. We've made a slight adjustment to our extraction reference, because if I just use the original one, which is referred to here, and again if I just hard code that for now, probably should have done it as a named range, we're not picking up these square brackets, but our compress lambda we just created included the square brackets. So if I change this expression, so we actually have to also include a literal opening square brackets. So we escape character and then this close bracket, open brackets, and then escape character and close the square brackets. We now get what we actually want. And I'm going to take all of these. So option 1, and for purpose of neatness, we'll just turn it to col. And now I can actually use a lambda. So I can start with a scan, and I'm going to scan over the initial value, which is a text string of nothing. I'm going to go over this array. I'm going to have to do a custom lambda where I have A and V, so accumulator and value, and I'm going to use my decompress lambda where the accumulator is the string which is being manipulated each time, and the triplets are the values. And that shows it working out step by step, but because I only need the last step, I can just put that inside reduce and we get our answer. So how are we doing? Oh, 9 minutes already and we're only on level 4. This is going to be a tough one to get done in time. Right, moving on to level 5. So level 5, we're now developing further. We're now going to go compression. So we're given a long sentence and a string that's inside this sentence or might be inside this sentence. So we start by working out the length of the string we're looking for. We then create a sequence that is of that length. And actually we need the sequence in reverse. I'm going to use my reverse lambda on that because we want to go 6 to 1. I'm then going to try looking at my string for each of these lengths. So I start with the longest and try and find it in the sentence. So I'm going to say find each of these within the sentence. And the first 2 return an error because they don't exist, whereas exe does at position 11. So we want to get that. So I'm going to call this using 3 as my optional argument, and then just take the first one of those because that will give me the correct position. I then, this is where I need to think carefully, then need to know the length. So how long is the string we found? So we're going to X look up this take position in the find range, returning from the reverse range, because basically where the first 11 is 4, which is the length of the string. And so our final answer should be just combining those together. So that is equal to that and a semicolon and then the second bit, which is this cell. But we will have some that return 0. So is that going to return an error? I think it is. So then we can just say if error means it didn't find anything. So we then just use 0 semicolon 0 to refer to an error. And if I just double check my level, in fact, I didn't even check the other ones. Level 3, we were all correct. Level 4, we were correct. Level 5, we're all correct. Okay, moving on to level 6. Now, level 6 is going to build on some of this work. So I might just copy the starting point, but we won't need all of it. So, and the text is in a slightly different place. So we want the length of the string, which we've got. We're on the, actually, yeah, this is slightly different because we're not using this sentence string over here. So they give us a sentence and then they give us a starting position. So the actual sentence we use, and this is where the instructions threw me because this 15 characters was kind of chosen arbitrarily, which took me ages. I was going, where is they getting this 15 characters from? And I couldn't work it out. And that was during the live case. And that's why I just didn't even get to try level 6 because that threw me off. So our sentence, they say, is basically the first 10 minus 1 characters. So we're going to say left of the sentence that minus 1. And then our string, they tell us, is the 15 letters after that. Okay, so then what we need to do is we need to go, might have to check my working on. So the text is that, our starting number is this, and our number of characters is 15. So that's the string that we're actually looking for. So now these formulas we need to update. So our length is the length of the string. That all updates are, we're finding that within the sentence. And I'm just going to double check this is working. So we're finding, oh no, this left should be pointing to the left of the string as well. Okay, now we're getting somewhere, and then we don't need these parts. This is where it starts to change. I'm just going to pause for a second to check my working. Okay, I hope I get this right. So the next thing we're looking for is the substring. So what is the thing we've actually found in the sentence? So we can use another X lookup. So we X look up the take position on the find range, returning the actual string range. So what it found, so it found 00 space H. We have to find where does that start. So we'll say find that string within the sentence. So it starts at position 2. How many steps backwards did we need to get to it? So the number of steps is where we take the length of the whole sentence, we minus the starting point, but then we're offset by 1. So that will be 8 steps. The next character is going to be, again, let me just check this because it's so complex. So we know that the next character will be this many characters into the string plus 1. So it's going to be the mid of the string. The start number is the length plus 1, and we only want to return 1 character. So the next character is the A, which is what they have here. And then we need to put this all together into an output where the format is going to be a square bracket. Actually, let's just use concat. So a square bracket followed by, in this case, the length, then a colon, then the number of steps back, then another semicolon, and then the character, which is hidden behind here, then the close brackets. And then if we get an error, which I suspect we will get some errors, so let's go to some throw us off. Do we get any errors? I'm sure, is it 82 returns an error? Yep, if we get an error, then that means it's not found, in which case all we do there, so I'm going to say let that be X. If error X, then what we want to do is we want to concat, and we can give it a square bracket 0 semicolon 0 semicolon, then close that off, and the next character, because we still need to return the next character, and then, don't need to use, and I should do next character because I've used concat, and the close brackets, and I've got something missing. If error, then I close that off. and it's not done that. So if X is an error, hold on a second. So if error X, then do this. What have I done wrong? Let me just pause. Oh yes, I spotted the error because my next character is also returning an error because if it's not been found. So actually we can't use P8. What we need to say is take the last character from this range because that's the single letter. So take from that -1. And there we go. So let's just go back to the example and we'll point to our output, which is, oh, I think I've got gone these the wrong way around. So it should be 08 and L8 there, and that gives us everything correct. And again, the same thing here. What we've effectively done here is we've done a step of decompression, compressing it. So we're taking real life text and turning it into a triplet. So I've done the similar thing over here where I've built a let statement just to show this working. So this is the same workings out as I've just done, and then I'm going to do the same thing where I'm going to convert this into a lambda, and we'll call this compress. So lambda. So our input is a sentence and a string. We can then remove F6 and F7 as our references inside here, but we'll just put them back in at the end as our arguments just to check it's still working. I need an extra closed bracket there. Okay, we get the same output based on, this is actually pointing to the wrong thing. If I put these here, it should produce the same, yeah, 84A. So let's now OA robot save lambda as, and we'll call this compress. And this is going to help us solve level 7 and also the bonus. We're at 16 minutes. Okay, we might be okay if I don't need to refer to my notes too many times. So example 7. So this is where we're effectively doing the whole sentence compressing at each step. Okay, so we start off, they actually tell us what the first triplet will always start off with a square bracket 0.0 because we haven't done anything yet. And then we need the very first letter of the string. That's always going to be our first. So let's do equals that string and the left of the starting point. That's always going to be the first triplet. If I could actually put the correct kind of syntax in, which I'm not doing. Then we need to know how many steps have we actually accomplished. So the middle digit here effectively tells us how many steps go up each time. So we need to extract that. So I'm going to use my text between lambda on that, and it's this text between the two semicolons. I need to multiply that by 1. It doesn't like that because I didn't actually use a semicolon here. I used a comma by mistake. Okay, and then we're always going to increment by 1. So this is the first step, and what we're going to do is we're going to take the left, in this instance the left of the sentence, based off the step. So that's all we've processed and compressed so far. So we've compressed L into this triplet. So what's remaining is going to be the mid of this sentence starting at this number plus 1. So we don't include that. And we need to use the length of the sentence as the number of characters because that will always give us enough. And now we're just going to roll down this using our compression lambda. So if I say compress, this is my sentence which has already been compressed, and this is the string that I'm searching for to see if it's within that, and I get 0.0 and then a space because after the I comes a space. That's brilliant. So if I just drag that down, that is not working because it's looking at the middle of that digit, but we also need to add the previous step. So now that is the second step. So when I drag this down, it's now going to be pointing at the wrong thing, so it needs to point at the one above. So it looks the same, but it is I space, and this will drag down, but also will need to be pointing at the one above. So actually no, this can point at that but stay as a fixed reference because we can always refer to that. And now should be able to start dragging this down and we should see the compression going on. Something going wrong there. What have I not referred to here? Just give me a second. Yes, I didn't have a locked reference here. Actually, this shouldn't be looking at the one above. It should be looking at that, but it should stay locked. And so that should now, yep. So we start seeing what has been compressed and what hasn't been compressed. And each time we're adding a new triplet. So if I just keep filling this down, I will eventually start creating some errors. So I'm going to go about 40 odd rows because I think that gives us more than enough. We might do a few more because I don't think the example is the longest. Where are we? Level 7. Actually, they're all fairly similar length. So let's just check. Obviously, the length of the sentence doesn't necessarily mean the length of the triplets, because if there's lots of repetition, it might be shorter. I think that will be enough. So what I'm going to then do, the last triplet finishes with nothing. So there's nothing after the second semicolon. So what I'm going to do is I'm then going to concatenate. Actually, I'm going to two-col all of this, but using 3 to get rid of all those errors. And then I'm going to concatenate that. And that should give me my answers. I'm going to data table that, go back to the case, and we're all good. And I'm just going to pause before I go into the bonuses. Okay, we are just under 21 minutes. I think we might do this in the time under half an hour, which was my aim, but required a lot of bonus work. So bonuses 1 and 2, you were only able to answer if you had correctly answered levels 2 and 3, because these codes then kind of decoded these questions, which I should have shown you before we started. So in the sentences of question 1, how many unique characters are there? Include punctuation. So the way I did this was I'm going to count all of the Unicodes of the concatenation of all of this. So if I concatenate it, then I'd convert it. I need to text string. I need to turn it into text characters. So text characters of that. So if I concatenate it into a single long text string, then split it by characters, then convert those to Unicode, so we get unique ones for each thing. Then we unique them and then count them. That should give us 60, which is correct. What is the name of the tourist in the book referenced to in question 78? So we go to question 78. It says something about on a world supported on the back of a giant turtle. I didn't know this reference, or wouldn't have got this reference, but if you Google it, which I did, and ask which the character is, who's a friend of Rincewind, it comes up with the hour 2 flower. So that's a Terry Pratchett reference. So 2 flower goes in as correct. Using level 4 description, decode the text in questions 17 to 26. So if we go to 17 to 26, which is this. So if I concat these codes, and then I'm going to use my level 4 formula. So I'm going to capture that. Go back to the case, but I'm not going to I need to split them. So let's regex extract those based on, I'm going to use my level 4 expression, hopefully, and then capture every single one. Great. And then I'm going to use my reduce over empty text string over that array, lambda av. This is my decompress lambda av, close that. And we get a question. It says, look at the sentence used in example 7. Who is the singer who sang the song this was based on? So we go to the level 7. I sit away, a dozen angels come to play to my feet. Again, a little Google tells us that's, if you know the song Angels by Robbie Williams, I sit and wait, does an angel. Rather than dozen angels, it's does an angel. But anyway, so the answer, the singer, was Robbie Williams, which, funnily enough, I didn't answer this in the live. I managed to decode the question, and I thought it was going for an exact match. I would have guessed Robbie Williams, but I didn't. So that was 40 marks I left on the table just for doing nothing. Okay, this is another one where we need to decode this. So if we grab the formula we did here, so we can just say, where has it gone? Oh yeah, let's just paste that here, point that to the correct cell. It doesn't like that because my reference has disappeared, so let's grab that reference and put in level 4 original expression, and then use the same formula to decode this. Let's put that underneath. So it says in questions 41 to 60, using the ratio of number of triplets / letters of answer, which game number was compressed the most? It took me a while to work this out. What it's basically saying on level, level 41 to 60, questions 41 to 60, which refer to level 4, it was basically, yeah, so what you had to do, you're basically looking at the middle number is the one that tells you how many steps you've saved, how much you've compressed it by. So what we needed to do is we needed to first we needed to regex extract each of these by our level 4 expression, and we want all of them, and I'm going to hard code that. I surely should have done this as a named range. And then I'm going to use my text between to grab the number in the middle multiplied by 1, and then if I sum those, that tells me that this one was only compressed by 7, and if I drag that down, and it wants the one that was done by most, so the largest number there is 54, which is the last row, which is level 60. So we have 60 as a second answer. And then finally, using level 4 encryption, encode the text of the first 2 chapters of the poem Beowulf. This is in the sheet Beowulf. There are 5,409 characters. How many triplets does it compress down to? So I'm going to make a copy of level 7. I'm then going to copy the text from Beowulf. Actually, I'll just refer to it. So it is I'm going to get rid of this. I'm also going to clear out the table because I don't actually need the table, and that's just going to slow me down. I'll go back to the case. Level 7, I'll just copy and paste these as answers so we don't lose them when we clear out this table, so we're not slowed down. So level 7, my expression is the same, my sentence. So this is now going to refer to Beowulf, and it's going to be a very long sentence. And what we're going to do is we are going to just drag this down. We're going to keep dragging until we can no longer see the text on the side. So if I do that, and it's going to probably have to calculate. So if I force it to calculate, you can see it has to do a lot of work just for those first few hundred. So we can see it changing, but it's still going on. So what we find is we actually get to around about 1,200 rows. So I'll go to 1,400. I will force it to recalculate, and now the calculation is even slower. We're getting up to 27 minutes, but we are, I think, going to get to it under 30, which would be, I'll be very happy with, but it's still being very, very slow. And there we go. We start getting errors because, there we go, at around the 1278th row, it stops working. So if I take all of these references here and go, and I get 1,272, but on the case, the answer, so when I tried this again, it actually gave it as 1273. So it's one of the, I think if you're wrong, sometimes it's always worth trying offsetting by 1 or 2. So I tried 1271 and then tried 1273, and 1273 came out correct. And I can't for the life of me work out why that is wrong, because the first one is definitely the first step, similar to our examples from before, and the last one definitely picks up the very last character, which is a full stop. And you can see that full stop in here. So I'm not sure why. I don't know whether there's a line break issue, but then there's line breaks throughout this, so it shouldn't really be that. So I can't for the life of me work out why I'm off by 1. So if anyone knows the reason for that, I'd love to hear that in the comments, because I genuinely don't know what's going on, why I've got it wrong. But yeah, so there we are, 28 minutes. Tough old case. Like I said, in the live case, how did I do? So I managed level 1, 2, 3, 4, and 5. I looked at level 6, and like I said, I was completely thrown off by this second line where it says, just zoom in a bit to the example, start position 10. I was like, yep, great, that makes sense. The 15 letters strung. I was like, where's the 15 letters? I was like, there's no 15 here. Am I meant to work that out? And I then went off and did the bonuses, and then it was only after I was like, oh, 15 characters has just been given to us as an arbitrary limit on it for some reason. Really not sure why. And then as soon as I had worked that out, I was then able to go through. So managed to get level 6, or not during the time, but would have done if I might have done if I hadn't misunderstood that. And then managed bonus 1 and 2. Bonus 3, I had an inkling as Robbie Williams, but I didn't guess it for some reason. Bonus 4, I did manage to decode that, but then couldn't make sense of what it was actually asking first time round. I'm not sure whether it was just to do with the wording. If we look down Actually, I think I've removed the wording because I removed the answer now, so never mind. And then, yeah, like bonus 5, like I said, I was off by 1. Not really sure why. Anyone who can shed any light would be much appreciated. So thanks for watching. We've managed that in under half an hour, just. So there we go. Thanks.